So for the first question, a bunch of you were a little bit confused with it. So the word sum, remember, means to add, and some of the digits. So numbers are made up of digits. Digits are 0 through 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the question is saying in the number 2016, if you added up the numbers or digits in that number, you would get 9. So it's asking you, what is the smallest number that is bigger than 2016, whose digits also equal up to 9 when you add them? So because we're looking for a number that's close to 2016, we want to try numbers that still start with a 2. And we probably want to see if there's anything that also has a 20, because we're trying to get the smallest number we can that's bigger than 2016. Now what you need to realize then is we've already got a 2. So that means our digits need to add up to 7. So 1 plus 6, that's 7. Well, what's the next smallest numbers that add up to 7? If 1 is already taken, the next smallest might be 2. And then 2 plus what gives me 7? 5. And so that's the answer to the first question. So this question was also kind of confusing to many of you. First thing you had to realize was that to be full, you needed to either have 4 math or 9 spelling books. And you know that the shelves are full. It tells you that. So it tells you that the shelves are full. So what you have to think about here is if 9 spelling books are on each shelf and you know there's 117, let's think about how many times does 9 go into 117. So you can do long division, short division, quick multiplication. You're going to find out that it goes into it 13 times. That means 13 shelves have spelling books on it. That means there are 7 more shelves to be filled because it tells you there are 20 shelves and each one is full. If there are 7 more that must be full and your spelling books are already taken, those 7 shelves must be with 4 math books each, which means there are 28 math books in total. So this question here, a lot of you did a really good job on. So what you wanted to think about was creating a new picture. So I'm going to pause the video and quickly make a picture just because then you don't have to sit watching me make it. And then you'll see one way of being able to do this question. Now, you can see that I started making a picture. And I can keep going. This one's row 1, this one's row 2, this one's row 3, row 4, row 5. You need to get to 8 rows. But one thing you have to realize about math is all about patterns. And so very quickly you're going to start to recognize, hey, my first row is 2, then it's 4, then it's 6, then it's 8, then it's 10. The next one must be 12, and 14, and 16. And there are my 8 rows. All I now need to do is add up those numbers. There's lots of really neat ways to add them up. One really cool strategy of adding them up is to pair them. 2 plus 16, 4 plus 14, 6 plus 12, and 8 plus 10. There are 4 pairs of 18. And when you do 4 times 18, you will get 72, which is the answer. So a lot of you tried to draw, which is totally fine. But when you draw, you're going to quickly see a pattern, and that pattern will lead you to the answer. So let's look at the next question. So again, the wording of this one confused many of you. So we're looking for a 4-digit number. Again, that's a number with 4 digits in it. Okay? Now, the number has to be a multiple of 3, 5, and 11. A multiple means something that those numbers will go into. So, for example, multiples of 3 are 3, 6, 9, 12, 15, etc. Multiples of 5, 5, 10, 15, 20. Multiples of 11, 11, 22, 33, 44, etc. So, you've got to think of a number that all of those numbers will go into. And then a multiple of 2 and 7, same idea. You have to think of a multiple that 2 and 7 will go into. The quickest way to think about that is to use multiplication. So 3, 5, 11, 2, and 7, that will give you a number that is a multiple of all 5 of those. Now you might be asking yourself, that's going to be a little bit hard to do. So there are strategies in terms of regrouping numbers, because remember, 3 times 2 and 2 times 3 are the same thing. So for example, you could regroup it into something else that would be easier for you to multiply in your head. So you could group it into, say, 2 and 5, which makes 10, and you could group it into 3 and 7 and 11, and 3 times 7 is 21. 10 groups of 21 is 210, so 11 groups of 21 must be 231. When I times that by 10, so this answer gives me 231 and this answer gives me 10, 231 times 10, okay, so that number is a number that is, that goes into, that is a multiple of 3, 5, 11, 2, and 7. So we found something that matches these two things here. But it says, Carrie says, that one digit has to be a 9 and nothing has to be a 6. So if 2016 works, that means that, if 2310 works, the next multiple that would work is 4620, except that has a 6 in it. The next multiple that would work, if we add on another 2310, we'd get 6930. But again, it has a 6 in it. So let's add another 2310. Okay, we're going to get 9240. And if we look back to what Carrie said, she said that a digit has a 9 and no 6s. That is the smallest number that will work, or I guess maybe the only number that will work. I'm not sure. I think that's the only number that will work. So to do this question, you had to know about what a multiple was, and you had to know that to find a multiple of many numbers, you multiply them together. Okay, let's look at this last one. Now this one was kind of, again, confusing for many of you. Again, a lot of you remember you're in grade 5. These are new to you. It's a grade 5, 6 level contest. Even if you're in grade 6, it's still early in the year, so don't really worry too much. What you're looking for here, though, are all the cubes that are completely covered by other cubes. So for example, this cube here on the top, it's not completely covered. Only the bottom of it is covered. So that one wouldn't be one that we're looking for. Likewise, every single cube on this bottom row that is 9 by 9, every single cube on that bottom row, nothing is underneath it. And so none of those cubes would count. So what you have to realize is that there's cubes hiding inside this shape, because you have your 9 by 9, and then this next row is a 7 by 7. So what I want you to do is picture there are some cubes that are underneath this layer that are hidden and covered by all sides. So that's what I want you to think about. So pictures might help you. So the bottom layer that's 9 by 9, none of them count. The next layer that is 7 by 7, and my pictures are not to scale, the outer layer does not count. But this inner layer, so the outer layer, this one here, this outer layer doesn't count, but everything hidden inside that does. Now, if that's 7 and that's 7, when I take away the outer layer, each cube was 1. So now, when I take off those 1s, this new length is 5. And same thing here, that's 1, and that's 1. So this new length is 5. So this inner part here is 5 by 5. There are 25 cubes that are all there. Now let's look at the next layer. Our next layer was 5 by 5. So I'm going to use, let's use blue for that one. Again, remember that the outer layer, this outer layer that you can visibly see right here in green, that one doesn't count. But this inner layer does. Again, if I take off my 1 and my 1 and my 1 and my 1, I'm left with 3 by 3. Or, 3 by 3. It's not working. 3 by 3, or 9 cubes that would be completely covered. Let's look at the next layer. The next layer is 3 by 3. Now I'm running out of color, so you just got to hang with me. So my next layer is 3 by 3, but the outer layer doesn't count. Only the inner layer. When I take away my ones, I'm left with a 1 by 1. That means I'm only left with one cube. Now, if you look at that, that means I'm talking about the cube that's directly under that one. There's a cube hiding directly under that one. Now, remember, that top cube doesn't count. So, the bottom doesn't count, and the top doesn't count, but these three layers have some cubes that are completely covered. 25 plus 9 plus 1 is 35, which is the answer. If you have any questions about these, please come and see me, and I can go over them with you.